Welcome to lesson 5.12. We'll be going over proofs involving isosceles trapezoids today. So let's go over the definition of an isosceles trapezoid. Just remember that an isosceles trapezoid has one pair of parallel sides, but it also have congruent legs. So let me give you an example. Let's say we got this right here. That's our, let me draw a better one. Let's say right here. If we have this isosceles trapezoid, so what it needs to have is one pair of parallel sides. So basically AB needs to be parallel to DC, but the legs need to be congruent. So AD needs to be congruent to BC. Okay, so we basically have to prove two things. All right, let's go over how is an isosceles trapezoid different than a regular trapezoid. You should write that isosceles trapezoid have congruent legs, but a regular trapezoid does not. Okay, so isosceles trapezoid, it has congruent legs, but a regular trapezoid does not. So again, in order to prove that a quadrilateral is an isosceles trapezoid, you must prove that one pair of sides are parallel and the legs are congruent. Alright, I went ahead and I already graphed it, but you can pause the video and graph your trapezoid. Looks like that the BD and AC are parallel. So we're gonna have to prove that BD is parallel to AC. Okay, using slope formula. That means they must have same slope. But we must also are gonna have to prove that AB it's congruent to DC. Okay, for that you're gonna have to use distance formula. That they have same length. And if we can prove both of those things, then we can say it is an isosceles trapezoid. Alright, I'm going to use slope first. So let's go and find slope of BD. I'm just going to substitute it. You're going to get 5 minus 2 over -1 minus -7. That's just 3 over -1 plus 7, 6, which is 1/2. And you're going to find slope of AC, which is just going to be 2 minus -3 over -7. Wait, which one I'm doing? Oh, AC. My fault, y'all. Alright, AC. So it should be 2 minus -3 over 3 minus -7, which is just 5 over 10, which is 1/2. Alright, we're halfway done. We just proved that up here it does have a pair of parallel sides because they got the same slope. Now let's do the other half. Let's show that the legs are congruent. So we're going to find length of AB. Now when it comes to AB, honestly, you can do the work and find it, but you don't really have to. You can just count it since it's a straight line. And you can see that AB is just 5. So all you have to do now is find the length of CD. For that, you're going to have to use distance formula. So I'm just going to substitute it in. You're going to get -1 minus 3 square plus 5 minus 2 square, which is just -4 square plus 3 square, So 16 plus 9 equals the square root of 25, which is 5. Okay, so that's it. We're done. We proved that one pair of sides are parallel. And then we also proved that the legs are congruent. So let's write down our sentence as always. We're going to write down ABCD is an isosceles trapezoid because one pair of sides are parallel and the legs are congruent. As we just proved. That's it. Now you're going to go ahead and do question number 2 and the exit ticket yourself. Good luck.